Hello everyone and welcome to today's session on design patterns and principles. Today we will be solving problems using design patterns and our focus will be on designing a notification system. Let's dive into the practical aspects of how design patterns can be applied to real world challenges. In this video I will be guiding you through the process. Before we jump into the system design, let's first look at the objectives of today. The goal is to reinforce our understanding of design patterns and principles through hands-on practice. We will solve problems involving common patterns like singleton, observer, and factory. In addition, we will review the solid principles and apply them while designing a real-world system, our notification system. Let's now move to our problem scenario, designing a notification system. The system needs to send messages through multiple channels like email and SMS. It must be flexible, scalable, and extensible, ensuring we can easily add new channels in the future. For example, if we want to add push notifications or WhatsApp, we should be able to integrate them without much hassle. The system should also handle large-scale notifications and future notification types like urgent or promotional messages. As we approach the design, we need to consider a few key factors. First, flexibility is crucial. New notification channels should be easy to add without changing existing code. Second, scalability. Our design must support handling a large number of notifications. And third, extensibility. We should be able to add new types of notifications in the future without disrupting the system. Now let's discuss the key design patterns we will use to build our system. The strategy pattern will allow us to choose different notification channels dynamically. The observer pattern is useful when we need to notify multiple users about events. The factory pattern will help us create instances of different notification channels based on user preferences. And finally, the singleton pattern will ensure that we have a single shared resource for global configurations like API keys or logging. Let's start with the strategy pattern. This pattern allows you to define a family of algorithms, in our case, notification channels. The benefit of the strategy pattern is that it enables dynamic switching between different notification channels like email, SMS, or push notification during runtime without altering the core logic of the system. Next, we have the observer pattern. In this pattern, we use it when our system needs to notify many users about specific events, such as sending updates. The observer pattern ensures that when one object or subject changes its state, all dependent objects are notified and updated automatically. Moving on to the factory pattern, which is useful for creating objects without specifying the exact class of object to be created. For our notification system, the factory pattern will decide which notification channel to create, like email or SMS, based on input from the user or system configuration. Now let's discuss the singleton pattern. This pattern ensures that a class has only one instance and provides a global point of access to it. For our system, we can use singleton to control shared resources like the configuration of the system or access to a logging services. Now let's begin designing the notification system. The central component is the notification object, which holds the message and the type of notification. We will create a notification channel interface, which will be implemented by concrete classes like email channel and SMS channel. The notifier class will handle sending notifications to the chosen channel. Step 1 is to create the notification channel interface. This interface defines the method send notification, which will be used by concrete notification channels like email or SMS. By using an interface, we ensure that we can easily add more channels in the future without changing the code logic. In step 2, we implement the concrete channel classes. For instance, the email channel class will implement the send notification method to send an email, and similarly the SMS channel class will handle sending text messages. Each class will have its own implementation of the send notification method. Next, we create the notifier class. This class is responsible for sending the notification. It holds a reference to a notification channel and calls the send notification method on it. The notifier class allows us to switch between different notification channels without modifying the core notification logic. In step 4, we implement the factory pattern. The notification factory class will create instances of different notification channels based on input. This pattern helps us decouple the logic of creating channels from the rest of the system, allowing us to add new channels easily. Now let's put everything together. In the main function, we first create a channel type like email. We then use the notification factory to create the appropriate channel. Finally, we use the notifier class to send the notification through the selected channel. This approach ensures our system is flexible, scalable, and easy to extend. So, what are the benefits of our system? First, it provides flexibility by allowing us to add new notification channels without changing existing code. Second, it scales well to handle a large number of notifications. And third, it's extensible, allowing us to easily add more notification types or features in the future. To wrap up, here are some additional practice challenges for you. You can modify the system to add features like retrace logging, retries logging, or rate limiting. You can also explore using the decorator pattern to dynamically add features like error handling. And if you are feeling adventurous, try implementing notifications using multi-threading or queues for improved performance. That concludes our session on design patterns and principles applied to the notification system. I hope you find this session useful and learned how to apply design patterns in real-world scenarios. Thank you for your attention.